Okay, so today the theme of my talk is about the dual notion of the multiplication modules and the generalization of the theorem of DeMarco-Rosati. So at first, let R be an associative ring with identity and let M be the left R module. We will write like M is like less or equal of M to indicate that fact that M is a submodule of M. So for the first time, the notion of the multiplicational modules were given by Barnard in his paper with the same title, Multiplicational Modules, in 1981. Later, a very big paper was written by Oskar Tugendbayer, where the author was learning a lot about multiplication models. And after that time, appeared a lot of different dual notions or generalizations of the notion of multiplicational module. At first, to indicate that module M is called multiplicational module if for every submodule M of the module M, there exists two-sided ideal E of the ring R, such that M is equal to Y multiplied to M. And I tried to, when I was writing my master thesis, I tried to discover some generalizations of the theorem of DeMarco-Rosati. And after that, I tried to study other dual notion of multiplicational modules. In this talk, now we will talk about co-multiplicational modules and openly multiplicational modules. But first, let S be the endomorphism ring of the module M. So if F is the endomorphism from M to M and G is other endomorphism from the module M to the module M, then by this F multiplied to G, we define in this way, like M of Fg is equal to M to F to G. Also for some submodule N of the module M, by such set, we will define all the endomorphisms from the endomorphism ring S, such that image of F is equal to MF that contains in N. And by En, by such set, we will define all the endomorphisms of the ring S, such that submodule N is contained in the kernel of the endomorphism F. And that such sets are respectively left and right ideals of the ring S. So, some submodule N of the module M is called open or respectively the closed submodule of the module M if N is equal to N with like named with a dot, N with a dot, yes, where N with the dot is equal to the sum of all images of the endomorphism F, where F is contained in the En. Respectively for the closed submodule, N is like equal to the N with a line, where N with the line is the intersection of all the endomorphisms F from the En.
Sorry, could you close this window that interrupts?
Which one?
Тут відображається зверху вікно, яке закриває частину екрану.
Що відображається? Я не чую. Ще раз, будь ласка.
Тут Zoom просто перекривається, вікно Zoom перекриває вікно вашої доповіді.
It's okay.
It's okay. I'm sorry.
It's okay.
Я просто зашерила екран.
Yes, please continue.
Вже все гаразд, все отлично.
Добре, дякую. So, once more, the N with the line is equal to the intersection of kernels of the endomorphism F, such that F belongs to En. Such types of modules and submodules were studied in the paper of Sun Bae by Sun Bae in his paper on submodules, including prime ideals of endomorphism ring R. Yes, and based on those definitions, we can give the definition that module M is called openly multiplicational R module if for every submodule N of the ring M there exists such two-sided ideal E of the ring R that N with a dot is equal to the E multiplied to M. And module M is called co-multiplicational module if for every submodule N of the module M there exists such two-sided ideal E of the ring R such that N is equal to such like 0 divided to ideal E. Yes, such modules, openly multiplicational and co-multiplicational, were studied by authors Ansari, Torohi, and Farsha Dihfar in their paper, The Dual Notion of the Multiplicational Modules. Yes. So I tried to like prove some characteristics or something for such multiplication models over not necessary commutative ring, for example, for associative ring. Yes, and the first proposition is that homomorphic image of co-multiplicational or respectively openly multiplicational module is co-multiplicational or respectively openly multiplicational module. Yes. And the second result that if R is a semi-local ring, then R module M is co-multiplicational module if and only if it is a cyclic module. Yes. The next result is that every finally generated module is openly multiplicational module if and only if it is locally cyclic module. And by the way, this proposition doesn't work for co-multiplicational modules. Yes, and the last one, that finally generated R module M is co-multiplicational module if and only if RP module MP is co-multiplicational for every maximal ideal E of the ring R. By the way, this proposition doesn't work respectively for openly multiplicational module. Yes, and based on those propositions, I tried to prove some generalization of the theorem of DeMarco-Orsatti. You know that in 1971, DeMarco and Orsatti, they published their paper, commutative rings in which every prime ideal is contained in unique maximal ideal. And they had a lot of useful results for commutative rings with the retractions of the prime spectrum to maximal spectrum and otherwise. And I tried to see how it works for multiplicational modules respectively for associative ring. So module M is called LPM module or left PM module if every prime submodule is contained in the up to the relativity in unique maximal submodule of module M. And here is the theorem that let M be co-multiplicational or openly multiplication module, and let M max of M is the retract of the spec of M, where max of M is the set of all maximal submodules of module M, and spec of M is the spectrum of M, like the set of all prime submodules of module M. Then M is an LPM module. And the corollary of this theorem is that every maximal submodule of co-multiplicational or openly multiplicational module contains unique minimal prime submodule. That's all. Thank you for your attention.